Hello everyone, in this video we're going to talk about systems of linear equations and specifically the method of elimination. So before we get into exactly what elimination is, let's go over what a system is and what a solution to a system is. So a system of linear equations is a set of two or more linear equations in the same variables, right? That just means that the two equations you're working with will have the same two variables in them, most likely x and y, right? So we're going to be solving for an x coordinate and for a y coordinate. A solution of a system of linear equations in two variables is an ordered pair, right? Just like we saw right here, an ordered pair that is a solution of each equation in the system, right? So whatever x is in the first equation, the x in the second equation has to be equal to the same thing. Same for the other variable, okay? All right, methods to solving a system. We've already done a video on graphing. We've already done a video on substitution. And so now we're going to talk about the last method, which is elimination. So if we look over here at the right side, we see some steps, kind of a four-step process. Step one is just if necessary, right? It says multiply, if necessary, one or both equations by a constant or by a number, so at least one pair of like terms has the same or opposite coefficients, okay? So same or opposite coefficients. Now, the reason I put a box around same, let's go down to step two here, okay? All right, so if we have the same coefficients, we are going to actually subtract the equations because that will eliminate one of the variables, right? The method is called elimination. It sounds like what we're doing, so we want to make sure we get rid of one of our variables, okay? Or we could have opposite coefficients, right? So one is maybe 2x, the other is negative 2x. So if we have opposite coefficients, we are actually going to add the two equations together, okay? Personally, I prefer adding the two equations, but whatever you're more comfortable with, whatever your teacher is comfortable with, or honestly, whatever the two equations lend you to as they're set up, right? You might already have two of the same coefficient, so it's easy to subtract them. Or you might already have two opposite coefficients, so it's easy to add them, okay? Once we have opposite or same coefficients, once we add or subtract, we will solve the equation. That will give us one of our variables, right? We'll get x equals 2 or y equals 5, whichever variable we're solving for. We will take that value and we're going to substitute it into one of the original equations to solve for the other variable, okay? All right, once again, we have three solutions. We could have one solution, we could have no solution, and we could have infinitely many solutions. The way these equations are going to look in terms of their solution is a lot similar to substitution, okay? If we get x equals a number and y equals a number, then there's one solution. If we get 0 equals 10, right, something that doesn't make sense, then there's no solution. Or if we get 0 equals 0, or two numbers that equal, the same thing, then there's infinitely many solutions. So we'll look at one example of each type of solution. Okay, so here's our first one. We have negative 2x plus 3y equals 4, and then we have 2x minus y equals negative 8. So kind of how we put our equations when we did graphing, right? We wanted to put our equations in slope-intercept form. Well, if we are using elimination, standard form is the best form for our equations to be in, right? Or we just want our variables to be lined on top of each other, right? So I want my x terms, then my y terms, my equal sign, and then my constants on the side, okay? All right, so most of these examples that you're going to see, they're probably already in standard form. The three we're going to look at, they're already in standard form, okay? So here we go. We look at our coefficients. We have a negative 2x, we have a positive 2x. So right there I know I can add these two equations because those two terms right there are going to eliminate, right? Negative 2x plus 2x, that will go away. So now I'm going to add my y terms and then I'm going to add my constants. So 3y plus negative y is like 3y minus y. So we get 2y equals 4 plus negative 8 is like 4 minus 8, so negative 4. And now we can solve for y. So we divide by 2 and we get y is equal to negative 2. So we're going to circle that, and then we're going to plug that in either for this y or for that y. Okay, I'm going to use the second equation, and I'm going to say 2x minus negative 2 equals negative 8. So when we solve this, 2x, this becomes plus 2 equals negative 8. We subtract 2. We get 2x equals negative 10. Lastly, we divide by 2 and we get x is negative 5. So now we have our two solutions, or what our two variables are equal to. We can put that together as our one coordinate solution, negative 5 comma negative 2. Okay, so that is our one solution example. All right, let's look at this one. Now we have negative 7x plus 7y equals 1, and we have 2x minus 2y equals negative 18. So we have negative 7x, we have 2x. Those are not the same, they are not opposites. We have 7y, we have negative 2y. Those are not the same, and they're not opposites. So step 1 says we need to multiply, if necessary, one or both equations. Okay, well I can't multiply 2x or 2y by something to get me to 7. Right, or by an easy number to work with, right? So we're going to actually multiply both of our equations here. So if we do that, we're just going to put parentheses around all the terms, and we're going to multiply by really any common multiple of 2 and 7, but the least common multiple would probably be the easiest to work with, right? So the least common multiple of 2 and 7 is going to be 14, right? So I want to make, let's say I want to eliminate my x variable, right? So I want negative 7x to be negative 14x, and I want 2x in the bottom equation to be 14x, right? So then we have opposites. So I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by 7. So that gives us basically like we're distributing here, and we get negative 14x plus 14y equals 2. Notice how we multiplied all three of those terms. On the bottom, we're going to do the same thing. Now we have 14x minus 14y equals negative 126. Now we can go ahead and add these, but watch what's happening. Negative 14x and 14x, 14y and negative 14y. So now my variables are all gone, right? So now I'm left with 0 equals 2 minus 126, and 0 is not equal to negative 124. So for this example, we will say there is no solution. Okay, so we've seen a one solution example. There's our no solution. So now let's see what infinitely many solutions will look like. Okay, all right, so we have 15x minus 5y equals negative 20, and we have negative 3x plus y equals 4. Once again, we don't have opposites or the same coefficients here, so we need to create opposites or create the same. I told you I like to add, so I'm going to create opposites. Okay. In the first example we didn't have to multiply either equation because we had 2x and negative 2x. The second equation, we had to multiply both equations, right, in the second example, because we didn't have a number we could easily multiply to make the same. But now here, we only need to multiply this second equation because I can make either negative 3x or y become 15x or 5y. I'm going to multiply this equation by 5. Okay, so my top equation is going to stay the same, 15x minus 5y equals negative 20. But now on the bottom, we've got negative 15x, which is what I was trying to get so that I could eliminate x, plus 5y equals positive 20. So now we go ahead and add these, 15x and negative 15x, negative 5y and positive 5y, so we get 0 right here. But now we have negative 20 plus 20, which also cancels, so we have 0 equals 0. That is true, so now we're going to say there is infinitely many solutions. Okay, and that is how you solve systems of linear equations by elimination.